Thank you so much for, oh, hi.
There we go.
Thank you so much for inviting me. I'm very happy to just tell you what I know about AWS or Amazon Web Services. I definitely don't work at Amazon or anything, but I've been using Amazon for the last 10 years. So it's been interesting to see this industry change and seeing everything move towards managed services, which is what AWS is good at. So basically, it's back in the day, you used to have a computer that you were responsible of managing, maybe in your building, maybe in a co-location service, that you were responsible of installing the software, making sure that it's powered to the internet and to the power too. And if it goes down, then you used to not be able to access that service. But thankfully, those days are over. Now we have solutions like AWS or Google Cloud or Microsoft Azure too, that do all of that for us. So yeah, thank you again for joining this quick introduction to AWS. My name is Laura Gonzalez. I'm currently the Director of Engineering at Zito. I've been there for 10 years. I started as a junior developer right out of school, with no experience with any of this. And, you know, with a few years, year by year, I kept learning more and more, and here I am right now. And I'm excited to see you guys forge your own path and get to your dream job at some point. I'm sorry if I'm a little sweaty because I have a lamp in front of me and I think that was a bad idea. But anyways, let me share my screen. I have a presentation for you. Oh my God, I forgot how to present here. So yeah, like I was saying, my name is Laura Gonzalez, Director of Engineering at Zito. If you want to know more about me, you can go to my website. I have a link to LinkedIn there, or if you want to email me and ask any question, I'll be so happy to help you with anything you want. So yeah, let's get to it. What is exactly Amazon Web Services? So Amazon Web Services is a cloud platform provided by Amazon. The Amazon that we know, like when you need something, you go to your app and order it and you get it on your doorstep the day after. That's Amazon. That provides very, very wide products of cloud computing services and application that are easy to use and flexible to you to run your applications or workloads. I would say it's a market leader in infrastructure as a service and platform as a service. I'll get into a few more details on what's the difference about those two. And they offer about 200 services or more than that. Every year there is a conference called AWS reInvent where they announce like 10 new products. And they have data centers all over the world. So yeah, like I was saying, what's the difference between infrastructure as a service, platform as a service, and even software as a service? These are terms that you'll run into, and I'm sure you've already run into, that is important to distinguish and distinct each service. So first, software as a service is like a product that is already built that you just go use. For example, Google Docs. Like you don't have to host anything or worry about anything to host your documents, your slides. The service is already built and you just use it for your own needs. The platform as a service is a type of, it's like in between a service and infrastructure as a service, where you can run and host your applications without having to worry about how am I going to host it? How am I going to configure this? Some examples is, I don't know if you guys are familiar with Heroku, that where you don't have to worry about provisioning anything, configuring anything. You pretty much just ship your code there and it's available to you. And the one that I'm going to be focusing a little bit more is infrastructure as a service. So basically, this is a model in which a company or a third party provides you all the compute services, all the servers, all the databases ready for you to use. So you don't have to manage them. Like I was mentioning, back in the day, you used to have a system admin in the building to figure out and maintain your database, like which was a physical server that sometimes you had to go and click restart, other if it was like stuck or it was running out of memory, and making sure that all the things were running. But with the increase of the need of having to scale your applications in the last 20 years, where everyone now has access to internet. Before it was a little bit more niche, where you would have to have a computer, maybe you would have to have the dial-up connection. So the internet wasn't as accessible as it is right now. So there wasn't the need to figure out how to scale all the things. And this is where companies like Amazon is starting to see that need, that the internet was here to stay. So we need to enable companies to run their products on the cloud in a way easier way without them having to manage any server. Any questions so far? Let me open the chat. Okay, cool. But one of the first things that when I was starting to figure out, like, okay, what is AWS, but like, how does everything work? It is not witchcraft. They're pretty much physical machines located in data centers around the world. And those machines are available to you for you to use to run your applications. So there is around 24 regions, and a region is just a big data center. And AWS has its own terms that you need to get familiar with if you're going to be working with AWS. But I like to just think about computers in a place that I can just go by reserve and run my application on. So yeah, AWS has about 24 regions all over the world. And within a region, they have their availability zones. And yeah, and each availability zone is independent from each other. Usually they have about 3 availability zones per region. And the benefit of doing that is that they need to be isolated. So let's say if there is a power outage in one of the availability zones, and when I say availability zone, just think about it as a building. And it's actually a data center. It's just a bunch of buildings with computers all connected between each other. So for every data center, you have different buildings, and every building is your availability zone where you have everything isolated. So if a power goes down in one of those buildings, the other 2 are still running. So yeah, AWS has its own rules, how they manage and configure their AZs, and they need to be only within 60 miles from each other. So the data that they're sending from each other, you have low latency networking. So they need to be close to each other so you can pass data around very quickly. There's currently 76 AZs. So yeah, this is like a good way of looking at how our region works. You have one region where you have your different availability zones within that region, and they're just connected between each other independently, but running independently and operating independently. I like to think about it as like having a city. You know, you have a city, it's a region, and then you have neighborhoods or like mini cities within the city. I like to think about it as the availability zone, and then you have your cables as your roads that connect you to other cities, so you can go from point A to point B. Pretty much very similar, but with data. Yeah, a fun fact, the first AWS region was US East 1, which was in Virginia, and it was first made available in 2006. If you think about it, this was like less than 20 years ago. So it's kind of crazy to see like how everything has grown and exploded in terms of demand and products out there in the internet and the necessity of like having all these services to make your application development quicker. So yeah, this first region ever, it's an old building with old infrastructure, old cables. So please avoid building services there. This is a pro tip, because like even at Zito, when we have outages, like AWS outages, when their services are down, mostly it's on US East 1. And yeah, apparently they never do tours and are super obscure about like their availability zones. This is for security. Oh, sorry. So they're super obscure about their data centers. And this is because they need to keep all the data secure. Has anyone watched Mr. Robot? No? Watch it. It's pretty cool. Wait, okay. The first thing also, when I was learning how to use and what different services AWS offers, was super overwhelming. They, like I said, they have over 200 services. So it's almost impossible to know exactly where to look at first. So what should you focus on? Yes, like that cat, that was me, pretty much, when I was first learning. I'm like, this is too much. But step number one, on anything you're doing, focus on your use case. It's super important to understand what you need. But even before understanding what you need to understand what you're building, what the requirements are. Once you have all that sorted out, you have a vision like, okay, I need an application and does this and that. You need to start thinking from the technical side now. How am I going to build this application? Does it need a front end and a back end? Is it just going to be an API, or is it actually going to be user facing, or maybe both? Does it need a database? Am I going to store information about people, about users interacting, about content? Let's say if it's a blog, where am I going to store the posts or the users? How are they going to access it? The next question, does it need to handle assets? What is assets? Assets are images, videos, libraries, whatever the user needs to see or interact with, the end user. Who should have access to my application? So the first thing, understand what your application needs, because that's going to tell you what you need to look for. The second thing is, okay, I understand that I need a database. I have my code, it's super cool code running, but right now I only have it on my laptop. How am I going to make it available to people to access my website or my application that I just created? Does it even need to be available to the internet? Or maybe your application, only one person, I don't know, all over the in the other side of the world in Europe is going to consume it. Maybe you shouldn't make it available. How much traffic does it need to handle? Like, is it only one person gonna use my application or 1 million? These are questions that when you start publishing your application, you need to think of. You hear a lot of stories of like startups that have a prototype, they set it live, and then they started getting a lot of traction and a lot of visits. And the first thing you know is like within 1 minute, the site goes down. You don't want your application to be that, because otherwise, why did you even like put it out if it's not going to be able to support that much traffic? And also another thing to think of is, where's my traffic going to come from? Is it going to be US only? Is it going to be international? Is it just going to be my school? Do I need to keep it like in a private network? So those two bullet points are very important to decide what you need to use. Any questions so far?
Yeah, I have a question.
Yeah.
You mentioned that the AWS East location is old, right? So people, you probably wouldn't want to build on it. So do you, as a developer, you have the option to place your database to a certain location?
Correct.
Okay.
yeah, it always gives you the option to map, and let me go back to one of the first slides. It always gives you the option to tell it which region you want to have your account on, or your service in your database. And this is important, like the question that I was just saying, like, who is this application going to be available to? If it's only going to be available to like US people, then any of the US regions work. But if it's going to be available all over the world, or you want to scale it out all over the world, then you need to think, okay, my application needs to be multi-region. And that's another configuration that you will have to make. So you need to have your database be multi-region, or have multiple databases talking to each other for each region. Otherwise, people in Europe, it's going to take like a minute to load your page. That's a good question. But yeah, so that was first thing you need to think about. What is my use case? How am I going to do it? What do I need? And how much traffic, and what does that traffic look like? Then the second thing, once you have all of that cleared out, then you can find an AWS solution for your use case. AWS has so many services, but try to consolidate the ones that are the most important and people use the most. The first one is compute power. So basically, what's going to run your code or your application. You have Elastic Cloud Compute, which is called EC2. So basically, that's a virtual machine. I remember that I was talking about the data centers, that just physical machines. So an EC2 instance is saying, hey, I want a computer that has 16 gigs of RAM and 4 CPUs. So basically, you pay AWS for that compute power, and they take care of allocating which computer, like on their physical network. You just get that compute power up to you, which it's basically comes with a operating system that you can pick from, and you can install and run whatever you need on those virtual machines that are available to the internet. The other type of compute that they offer is Lambda, which is more on a serverless architecture. I'll get a little bit more detail in that area by the end of the presentation. Another very popular ones are ECS and Kubernetes. So I'm not sure if you guys have worked with Docker. So basically, that's packaging your application in a Docker image, and then you can ship that application anywhere. ECS and Kubernetes are one of the two main systems that can run any Docker application or Docker container. And within your container is where you push your application, you have your environment contained in that container, and orchestration systems like ECS and Kubernetes can just run it and scale. And bigger companies, even Zito, we use ECS and Kubernetes to run all of our applications. And even like companies like Lyft, Uber, Netflix, they use Kubernetes a lot. Databases. For databases, you have your relational databases, RDS, where you can configure your database engine. You can select MySQL, Postgres, and I don't know which other ones, but those are the two most common. And then you have other type of databases like caching, Elastic Cache, where you can configure using Redis engine, or what's the other one, Memcache. And then you have Aurora too, which is a serverless database. So basically, you just send commands to your Aurora database, and it takes care of managing the infrastructure. It's like the serverless side of things is a little bit more obscure. Like you don't have to say, hey, I want a database that is 16 gigs of RAM. For RDS and Elastic Cache, you have to specify how much compute you need for your database. They also have solutions for content and storage. Remember my question of does my application need to store images? Like, how do you store images? You cannot just have them in your computer. You need to have the end user be able to see the image on the post if you have like a blog application. So services like S3 are very common to store files. And then you have the elastic block storage, EBS, that are pretty much the hard drives that get attached to the EC2 machines. And then you have your CDN, your content delivery network, which makes all of your assets, your images, video, libraries, available to the user closer to the location. So AWS figures out like, okay, if this user is visiting from New York, and let's say you have your region in the West Coast, AWS figures out and caches your image that is located in the West Coast on the East Coast so that it gets served faster to the end user. So that's what the CDN does. We also have lots of developer tools to deploy your code, like code build and code pipeline. They have lots of services for security and identity. IAM and Cognito, I'll talk about them a little bit more. And monitoring as well. They have services for monitoring. The main one is CloudWatch. Monitoring is super important once you're running an application. For example, if you have a visitor or user spike on your website and you're using like only 8 gigs of RAM on your database, how do you know that you need to scale up? So services like CloudWatch can let you set alarms where the CPU, if the CPU spikes over 100%, meaning that it has a lot of load, then you should probably upgrade it. So it's able to handle all of the traffic. So this type of scalability concerns are very important, which it goes back to my question, how many users does your application need to support? Any questions so far? I know this is a lot of information. I'm not sure how familiar you are with all of these services, but again, try to map the services to your actual use case, and AWS has a solution for any use case you have. Okay. So yes, some of the benefits of using AWS is that it's easy to use. Once you log in, you have the UI, or they call it the console, which is the website that you go into, and then you can click to, for example, create a new database. You can click and select all the things that you need to create it. Or you could also, they have a lot of command line tools. So you use your terminal to say, hey, AWS, create database. I want it like this, like that, or reference a file and do everything through the terminal. They also have, so for example, let's say you want a service that, a database, but you don't want to use RDS for some reason. You want to use MySQL, but you want to run it on an EC2 instance, which is a virtual machine. They have a huge marketplace where you can say, I want to run an EC2 instance, and I want that EC2 instance to have MySQL installed. So the minute you click on it, it creates that machine and has all the software that you need installed. So they have so much software, pretty much any software that you can think of that you might need to install it on a computer, they have it available. It's also very flexible. Like this previous example, like if you need like a MySQL database or a Kafka cluster, they have so many options for you to pick. And then for the other services too, for example, the RDS one, you can select if you want MySQL or Postgres, or if you need to run a serverless code, like a Lambda, you can pick whatever language you need. They have all types of languages, all types of versions. So it's very flexible. I'm sure that whatever you need, they will have a solution for it or support for it. This is one of my favorite. The next one is very cost effective. And I'm saying this is one of my favorite because this is what I do day to day, making sure that our application is gonna scale and run efficiently. AWS, first, they have a free, they have free compute. And once you go over that, you just get charged by the usage. So if your application doesn't have a lot of traffic, you only pay for the traffic. So it's important to design your application based on your traffic here. But AWS gives you all the tools and the pricing models to plan everything ahead. Reliable, it's very reliable. They have some SLAs. I'm not gonna say it's always up because it's been down a lot lately. I would say it goes down maybe 1 or 2 services like once every 2 months or so for like maybe 30 minutes at most. Still reliable and way more reliable than having you run it from your computer, or from your house. It's very scalable and high performant. Like I was mentioning, the serverless model, for example, you don't have to worry about saying, hey, I want this many RAM or CPU. It knows how to handle the traffic, so you don't have to worry about that. And the last one is secure. So they're very, very strict about security. So once you start with, let's say you spin up an EC2 instance, a virtual machine, usually you cannot access to it. You have to configure the access. You have to route the internet traffic to your machine so it's accessible. Any questions so far? I have all the users on there. I'm gonna put it. Okay, so I was talking more about like when to use what, make sure that you think about your use case to pick the solution. Now I'm gonna talk more about some of the terms that you need to be familiar with if you're gonna start building a service. So like the question that Joyce asked, like, hey, how do you know which region, or do you have the option to pick a region? Yes, and where everything is selecting your VPC, the virtual private cloud. What is this? So basically your VPC is just telling AWS like, hey, I want compute needs on this region. So you have to, so basically it's a virtual network that you tell AWS that you will use their networks on this region for these ACs. And then when you launch like your database or your EC2, you have to tell it, hey, I wanted to run it on this VPC. This is a diagram about how the VPC architecture is being built. It's very similar to the other one. So basically you have your region. Within your region, you have your availability zones, and that's where you define your VPC. And you say, hey, within this VPC, I have this subnet and I have this route table. So it all comes like when you get a request, how do you route that traffic? So it for this one, honestly, this took me maybe like a year or two to really understand. We first had an actual DevOps person that mapped and planned all the VPC. But this is very important to understand if you need to scale, because if you need to be available in multiple areas, then you need to create different VPCs per region and make sure that you configure them in a way that they can talk to each other. The next one, I already talked about it a little bit, the AWS Elastic Cloud Computing, or EC2. They're just virtual machines that you tell AWS, hey, you need a machine that has this specs, this amount of RAM and this amount of CPU, and I want to run this package, or AMIs, which are just prepackaged images. Like I say, if you want to run MySQL, you can just say, you can just tell AWS, hey, I need a machine with this and that, this specs with MySQL. So click and then it like creates it for you. You can create security groups like, hey, I only want people from this IP to access this machine, or people from this region, or you only want another machine, for example, to access this computer, sorry, virtual machine. Then you can change the instance types, which is the sizing at any time. And they have different pricing models for EC2, like on demand, reserve, etc. So yeah, this is the basic architecture of an EC2 instance. You have your instance, and then you attach a EVS volume to it. I remember the EC2 instance is just the computing power. So it's just saying how much RAM, what it's going to run. But the hard drive, or it's not called a hard drive, it's the EVS. But if you were to compare it with your computer that you have right now, it's a hard drive. You can tell AWS, hey, I need a volume that is like 6 gigs or 100 gigs or a terabyte, and please attach it to my EC2 instance. Any questions so far? Sorry for my... Oh yeah.
Curiosity, sorry. Just out of curiosity, you may have mentioned it once before, but what does EBS stand for again?
Elastic Block Service, I think.
Cool, thanks.
Yeah. Or block storage. One of the two, I'm sorry. Let me Google it real quick. Oh, Elastic Block Store. So yeah, it's pretty much like a volume that you can attach to your EC2 instance, and you can change the size anytime too. Good question. One of the other important things that you need to know about is the identity access management, which is called the IAM or IAM. So basically, it's just a user access management for any AWS account. You can create users, and your users can be a person. Your user can be a key, like an API key to access your service. Your user could also be another machine. So AWS is huge on security. So by default, everything is blocked or everything is not accessible. So you need to create who's going to be using your services, who's going to be accessing them. You can select users, policies, and groups. A policy, for example, is like saying, I want to deny access to everyone except people in this group. So you can be specific of what you can attach to your instance or to your service. And then in the group, you can say people in this group are, you can say these machines or my engineers. So it's super flexible, but very important to understand this because you need to configure the access to all of the services that you spin up. So yeah, this is a diagram of what are the most important things in AWS IAM: the permissions, identities. An identity could be a user, a group, a role. All right, on the AWS databases, we have RDS, Relational Database Service, where you can spin up a MySQL, a Postgres. We have Document Store, that's their own version of like MongoDB, for example, that is not necessarily like a table. It's more like a JSON object stored in their database. DynamoDB, Aurora, which is a serverless database, Elasticache, and Q Systems. They have a service called SQS. One of the first things, honestly, when I was learning and like using RDS, was to compare, okay, what's the difference between creating an EC2 machine and installing MySQL versus creating an RDS instance? What's the difference? So the main difference is like with an EC2, you're just spinning up a virtual machine. So it's your responsibility to monitor that instance. It's your responsibility to install the software, to perform any security upgrades, and to make sure it's running. So like if you have a CPU spike, you need to SSH or log into the machine and see why that spike is happening. Or if it's down, for example, in your EC2, you need to log in and go check the logs manually. So it's as if it's running in your computer. Versus if you use an RDS service, you just click, hey, I need a MySQL database. And you don't have to think about how it's running. You just get an endpoint that you can use and save everything. And that endpoint that they provide is like your interface to the database. So you don't have to worry about how much memory it's running. They do give you like monitoring dashboards so you can see how it's performing, but you don't have to worry about installing it. Or you could install or do upgrades on the versions and stuff, but instead of manually having to type all the commands on a virtual machine, you just click a button and it does all the maintenance for you. So honestly, one of the initiatives that we've been doing at my company is move to managed services, because that way you don't have to have a DevOps person having to run all the commands to install things, upgrade, to monitor. Everything is just ready and available for you. And honestly, that's where everything is going. Like even at our company, we used to have like a team of 3 DevOps people installing everything on EC2 instances, configuring everything. Nowadays, as of like, I would say 5 years ago, like all the developers, the full stack developers, we're responsible of managing this because it's so easy. Literally, you just like click a button and you have a database. You don't have to like worry about which package you need to install, what dependencies, how to maintain it. Everything is ready for you. And and a lot of services are moving towards that direction. Like I said, I feel like every conference, AWS conference every year, they're like, oh, we have a new managed service, which is great. So I would 100% advise you to go towards that route so you don't have to worry about how to maintain it and scale it. And I talked a little bit about this already, but they also have AWS storage solutions like EVS, attaching a volume to a machine, or S3, which is a bucket where you can create directories and then you can store any type of files on that bucket. And then this is an example of an application that is running in AWS. You might think which services you need to think about if you want to have a simple application. In this case, you have let's say you have someone type in example.com. That is gonna go, like your domain, you have it configured to Amazon Route 53. That's what's gonna map your domain to your load balancer. A load balancer is just an interface to say, okay, any request coming from here needs to go to this machine. So in order to route example.com to your EC2 machine, you need to set up an Amazon Route 53 record and create your load balancer so you can route the traffic to your web server. Within your web server, you can set up auto scaling groups. So you can say, hey, if I need only 3 machines to handle all the traffic, or you can even configure it to auto scale automatically. Like, hey, if I'm getting above this amount of requests, please scale it up to 100 machines. So that's the beauty of this, that you don't have to really worry post deployment or post building your application about maintaining it and have it be available all the time. You can just configure things to auto scale and handle the traffic without you having to be always like monitoring. And then for, like I was mentioning, for assets, let's say they come from mediaexample.com. You upload your assets to the S3 bucket, and then you can configure your CloudFront, which is the CDN, which is the content delivery network, to cache that asset to be closer to the user that is trying to load an image. So instead of taking a second to load it because it's on the West Coast, AWS caches it on the East Coast, and then the image loads way faster because it doesn't have to go all over the country on a data packet in order to load it. So it's very, very important to have this considerations in mind when you're designing your application and how you're going to store it and which services you might need. And another question, what if I just want to run my application without having to manage a server? Because if we see in the previous picture, you still have to manage your server. You still have to think about how you're going to deploy your application to this server, worry about the auto-scaling groups, the security groups. But with AWS serverless, you can replace all of this block in the middle with something called Lambda. So I see a lot of applications in the last maybe 5 years too that are moving to serverless architectures. So the serverless architectures are super easy to develop on them because you don't have to worry about or think about a server running your application. Basically, you just package your code. Let's say it's a hello world, and you just put it on Lambda, and AWS takes care of spinning up a Lambda per request. So, and the pricing model there is that you just pay for Lambda executions. It's actually super cheap. I forgot the exact number, but it's super cheap. You can run like millions of Lambdas, meaning millions of requests for like a few bucks. And the beauty of it is that you don't have to think about, hey, how many servers do I need? How much memory is it gonna consume? AWS takes care of that. All you have to take care of is packaging your code and putting it on a Lambda. And then AWS takes care of spinning as many Lambdas and managing all the infrastructure to run your application. And the same thing with a database. Like if you don't know how big you need your database, you can use DynamoDB or Aurora, and AWS takes care of scaling it up to supply your needs or your volume needs. And that's pretty much it. To kind of recap, I know AWS is overwhelming. Going back to the first slides, you have to think about, okay, what do I need? And how am I going to make it easy for myself not having to maintain it? I would have that mentality every time you need to build something, deploy something, make sure that it's available, but at the same time, make sure that you don't have to spend a lot of time configuring it. And thankfully, AWS gives you all of this out of the box. Any questions?
I did have one. So you mentioned, I believe it was the VPC. I think, and if I'm correct, that was the virtual, what was it? I guess like region. I'm trying to remember the name. There were a lot of terms. But yeah, so that was based, obviously you have that based, yeah, exactly. You have it based in an availability zone, but then, so then basically you can set that, for example, like you're based in, I don't know, like the one in Oregon, but then you can say that based in, what was the other one? Yeah, in like the one in the UK. Is that do I have that correct?
Yeah, then you need two VPCs. You can only have one VPC in one region.
Oh, okay.
And remember, a VPC is a virtual private cloud. So you're telling, hey, for this data center, I want like this small chunk of servers or like space, and that's your VPC. And the reason, that's a great question, because the reason they do it like that is that for a region and a VPC can have multiple availability zones, but just one region. And the reason that you should have only one VPC per region is that you should put your database and your application in the same VPC so that the network latency is low. So if you have a request coming to this region, they're going to be able to see the data immediately versus having to go all the way to Europe to get that information.
Okay, that makes sense. Thank you.
Cool. No, great question.
I have a question on the role. So is this a job to be determined by the backend developer, or is there a specific role?
That's a great question. Like I was mentioning, I feel like in this industry, everything changes so much. Back in the day, you used to need to have a sysadmin or system administrator being able to manage the infrastructure for your application, like your database running on a computer that you have in your building. When we moved to cloud services, basically you used to have a DevOps person that was responsible of configuring all of this, like setting up the VPC or setting up your database. I feel like nowadays most people, full stack developers and backend developers are the ones responsible of setting this up and managing this. You still have big companies that have a group of DevOps people that ensures that their developers don't have to think about the infrastructure, managing the infrastructure. But for smaller companies like startups, usually a regular full stack developer need to be aware of all these things. Or even if you're a front end developer, you need to be aware of how are you going to handle assets? Like how are you going to load those JavaScript libraries? Being aware of CDNs and S3. If you're a backend developer, you need to be aware of your databases. How are my applications going to get the information from? How are they going to run? So it depends on the company, I would say. But it's good to know about how things run and work at the very least for any position, I would say. But as companies are moving more to managed services, you don't have the need to have a DevOps that ensures that your database is always running, because AWS takes care of that. Good question.
Any more questions?
Hi, Laura. Thank
Hi.
you so much. Thank you so much for presenting today. Overheard you talking about when you first did AWS was just a bit overwhelming with all the 200 services. Because we are in a learning environment, could you give us a couple of tips or strategies that you took to calm down that overwhelm? And as we can see, you actually learn it because you're a director now. So just that process.
Yeah, no, that's what I tried to put this to 2 slides. In order to overcome how overwhelming it is, just think about your application and your use case. That's going to make you focus on the services that you need and the solutions that you need to in order to put your application live, because that's the end goal. You have an application, but how are you going to make it available to people? How are you going to deploy it? How are you going to make sure that it stays up? You don't want to push an application that the minute it gets more than 2 users is going to go down, you know? So that would be the first thing I would think of. And the second tip, honestly, I would, if this is a lot, I would start with serverless, because you don't have to think about a machine running your application. With serverless, you just think, okay, I have a code and I need to have something to run it. I'm going to give it to AWS Lambda, and it's going to take care of scaling it up, scaling it down. And it makes it takes the operational overhead away from you. And the minute you need to start working on a bigger system that you cannot just have, for example, a big complex system run on Lambda, and you need to have multiple machines, then it's when I would use to start getting familiar with EC2s and how to connect them and how to work with the security groups. But honestly, to start with, I would start with serverless. And at Zito, for example, we use both. We use serverless for some applications, for some APIs that just need to grab the request and put it on a database, and it's super scalable, super easy. For more complex systems that have like microservices, so like we have like 60 Java applications, we use Kubernetes because it's easy to see in one place all the applications and they need to talk to each other. We use EC2 instances to run systems like Kafka, which is a queuing system. So let's say a user sees a page, we push an event to Kafka, and Kafka is responsible to publish that event to all the consumers. So it's like more complex distributed systems that AWS at the time, it's funny because AWS at the time didn't have a managed solution, but they do have it now as of like 2 years ago. One of the initiatives is let's move to managed services, because that way we don't have to manage like 20 EC2 instances. Every time there is a security update, we have to do one by one. And that operational overhead, AWS takes over it with their managed services. So I would definitely 100% go with that route. The less you need to think about how to maintain your application, the best. So serverless and managed services. So you focus on your application and your use case.
This might be a question conflating two ideas that may not be related, but if they are, I think I'm on the right path. When you're at a point of thinking about EC2, how important is containerized knowledge or like Kubernetes knowledge? Like at a certain point, is that like the same level of computing power that like you're trying to think about for an application?
Yeah, that's a great question. So for containers, you do also have to think about compute power. But nowadays, there is platforms like Kubernetes or ECS that take care of dealing with EC2s. So you just install, for example, even AWS has its own managed Kubernetes. It's called EKS, which is what we use currently at Zito. And it's super simple. You just click, you just tell AWS that you need an EKS or Kubernetes cluster, and it takes care of creating the EC2s for you. So you don't even have to it does run the containers on the EC2s, but it installs and it spins up and scales the EC2s automatically for you. So EC2s are still used to run the containers, but you as a developer, you only think, okay, I have a container and I need to ship it somewhere. Hey, AWS, please help me ship my container and make it available to people. So that's where you can spin up EKS and have it run your application.
And then if I can ask like some lingo terms, like what I'm thinking of that concept as like EC2 is like, these are like tools that are being abstracted out to different layers. What if I'm speaking with somebody who knows AWS, like how am I talking about that relationship between like the EKS, the EC2s, and like what like my needs are? Are those just abstract layers, or what kind of lingo do I use there?
It depends on your application.
Okay.
Like if you're talking about like, hey, I need to run a specific software, but I just need to run it in one place, you could use EC2, like you just need a machine to run it. But if it's a complex system with a lot of containers and they need to talk to each other, then you would pick something like Kubernetes.
Okay, cool. Thank you so much.
Yeah.
Okay.
But again,
sorry.
Oh no, I'm just going back. It all depends on the use case.
Yeah, it definitely feels like it's like similar to like something I would expect in the medical field. Like there's very fine-tuned instruments for every single scenario.
Yeah. But you as a developer should just focus on like what's easier for me, to be honest. And these cloud services are getting cheaper and cheaper. So the less you have to worry about maintaining any of them, it's best to just focus on developing and pushing your applications up. Good questions. I love it.
All right, we've probably got time for one more if there is one. But if there isn't, Laura, thank you so much for coming in. Really appreciate it. Covered a lot of ground there. That was awesome. And yeah, hopefully we'll see you very, very soon.
Cool. Awesome. No, thank you everyone for listening to me as I was sweating in front of this lamp right here. And if you have any question or if you need any advice, especially on AWS or whatever you need, feel free to reach out. My website is right here, lauragonzalez.me. And I have links there to my email, LinkedIn. Feel free to reach out and ask anything.
That's very kind of you. Thank you so much.
Of course.
Thank you.
Thank you. Bye-bye.
Bye.
Take care. Bye-bye, Nee.
Thank you.